Okay, Unit 6, Day 4a. This is about polar form, it's called. And when you hear the word polar, you maybe think of the North Pole, the South Pole, polar bears, whatever. But that's literally kind of what we're looking at here. If we're looking at polar form, it's almost like we're going to be looking at a grid, and say this is the North Pole or the South Pole, and then looking down at how the Earth goes out over that. So kind of a circular, looking at a sphere kind of grid. It kind of works the same as rectangular coordinates. You think rectangular coordinates, everything was a rectangle, hence the name. And then when you're given coordinates, an x and a y, the x told you how far left or right to go, and then the y told you how far up or down to go. And so you go right and up or right and down, whatever it might be, but everything was squares. Now, with polar coordinates, we're going to give you two numbers. Instead of saying how far left or right, how far up or down, the first number is going to be how far from the pole you're going to go, and then the second number is at what angle. Okay, so we use r to represent the distance, which it doesn't explicitly say this like at the radius, but I'm assuming that's where it came from. Think of it as a circle, and that's how far the radius, or how far out you're going to go from it. And then theta, the second number, is at what angle. So r is the directed distance from O to P. So P is some point out there on the graph. Maybe I'll just point at this point. So there's, say, point P right there. Theta is the directed angle whose initial side is the polar axis. So this is the polar axis right here. So you always think we start from straight to the right, and then we open up counterclockwise. And whose terminal point is the ray OP. Now again, we're doing coordinates again too, so don't get confused. We're not making vectors here, but it is gonna, all the same stuff's gonna apply. Okay, so it's gonna look like we're doing vectors. We're actually doing coordinates again. So coordinates with parentheses. These are parentheses here. They're not vectors with a magnitude and a direction, but this is a distance in a direction. So it resembles it, but it's not an arrow. It's actually a point out in space. So again, a point O is here. Point O is the origin. Here's the polar axis, and then we open up counterclockwise. We open up theta degrees, and over here would be our point P. If we're looking at all this stuff over here. So just some practice here. We're going to plot these. We're going to plot these points. And you see some of these are negatives. I'm going to tell you how to handle those. Some of these are degrees and some of these are radians. This should not. It's what happens when you copy and paste and then you just edit. So I copy and pasted and the degrees stay and stay. So these are actually radians. Those aren't, so ignore the degrees there. But, and honestly, I wish they would do it the other opposite direction. I wish they would give you the degree first and then the distance, because you can't really do the distance yet until you know the degree. But, looking at this polar coordinate over here, it's usual, that's pi over 2 or 90, 180 degrees or pi, 270, 3 pi over 3, and then the full circle coming back. So we don't actually do a full circle. It starts back over at 0. So if you look at this, this is like 45 degrees. This would be 30, 15. This would be 60, 75, 90. Kind of think of it that way, and you can fill in the rest if you want, but we'll fill it in as appropriate. So I'm going to go 15 degrees, open up, and I'm going to go out 4 units. So this would be 1 unit out, 2, 3, 4 units out. So right there is point A. Okay. Now the negative, how you handle that, you're still going to open up 60 degrees. I'm going to open up 60 degrees. So I'm facing that way, but then negative would be the other direction. So I'm going to -3, which means I'm going to go backward 3 units to here. So here's point B. So the negative means goes backwards. It is aiming 60 degrees, but then step backwards instead of forward. There's multiple ways to write this, and so I could write this exact same point a different way. So maybe try to maybe pause the video. I'm going to pause my video and put all the points in here, but just practice, putting these in here and see how you do. So pause the video and try it out. Okay, so here they are. So maybe check them out here. C was 105 degrees, so that's going to be a little bit past 90, go out 5 units, 1, 2, 3, 4, 5. This is pi over 2, which means here, but then you're going to go instead of going up, you're going to go backwards 4 units. So there's D. Open up pi units, but then go backwards 6 units. So there's E. And then 225 is here, and then 1, 2, 3, 4, 5. I know this says negative, negative this way. So those negatives really just mean if you're in that first quadrant, you go left and down this way. But that negative really should just say 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3 with no negatives. And then you figure out what backwards means to you on that angle. Now look at point A and maybe pause the video. I want you to write down 2 equivalent polar points for A. So think about going opposite directions, think about radians versus degrees. You can go more than 360 and it's equivalent, it's going to be the same point. We typically don't go more than 360, but it would still be correct. So think about 2 other ways to write that. So here's 2 answers I put. So I thought, if we want to go out to this point, I could go 195 degrees, but then go backwards 4 units. That'd get me on the same spot. Or I could open up pi over 12, put it in radians, and then go out 4 steps. You could also, put this, what would that be? 13/12 pi, and then -4, and back it up 4 units. 2 equivalent polar points for point A. If you want to pause the video real quick, you can try them out and see. Whoops, see 3 pi over 2, or 4, 270. Put those in there. So that was for point 4, which is also letter D here. So 3 pi over 2 out 4 units, and then 270 out 4 units would be some equivalent ways of putting that. So just finding all the polar coordinates of a point, all the different ways you could possibly do it. You let P be r theta, then you could basically just add any number of 2 pi's, or you could do the negative r, which means go backwards, and just add an odd number of pi's. So you could add 1 pi, 2 pi, 3, or 1 pi, 3 pi, 5 pi, because that would give you that 180 turn and then go backwards. Yeah, so there's some different ways of doing that. So let's go to the backside now. Let's talk about how to convert from polar to rectangular. So if I give you this in polar form, well, how far? So this says open up 5 pi over 6 degrees, which is going to be a little bit less. It's going to be pi over 6 less than a half a turn, and then go out 3 units and put a point. Well, how far would that be? Well, I know it's going to be left and up. Well, how we do that then, this is kind of how you did vectors. This is going to be the x-coordinate you use cosine for, and then the y-coordinate you use sine for. So this would be 3 cosine of the angle 5 pi over 6. That'll give me my x-coordinate, and then 3 sine 5 pi over 6. So I'll type in my calculator. Make sure you're in radians when you do this. Make sure you're in radian mode. So that'd be that coordinate, which makes sense that I want left 2.6, up 1.5. So that'd be the exact same spot on the coordinate plane. And this guy, even though it says -200, I can type in the calculator -200 and it'll take care of it for me. So 2 cosine -200 to sine -200. Put them in the calculator. And if I do this right, I messed up here, so I had to restart or edit the video. So think -200 degrees would be opening this way. That's where I messed up. So it'd be about 20 degrees past that semicircle going this way, and then it's going out 2 units. So it's floating around 2 units away. Right there's that point. So my answer should be -x, +y. If you type this in the calculator, again, make sure you're in degree mode now. Make sure your calculator's in degree mode. There should be -1.88 and then 0.68, which left and up, and that makes sense. So to generalize, converting this, and this one's, we've been doing this the whole time. We did this with vectors. So a lot of it's like, hey, I already know how to do this. Why are we going over it? Well, it's just a new concept with the exact same process. So if you're given r theta, then if you want to convert to polar coordinates, that'd be r cosine theta, comma r sine theta. And that works every time. Don't have to think about it. Just put the r and the theta in, r and the theta with cosine and sine, and get your answer. Going the other direction, we do have to think sometimes. Unfortunately, when we're finding the angle, remember when you use inverse tangent, basically you only get answers on the right side of the unit circle. So what if my angle is on the left side? Well, I got to do a little bit of fixing on that. So when I say -4, 3, when I got this point, -4, so here's -4 and then up 3, that's not in the right two quadrants. And so when I do inverse tangent, it's not going to give me the exact right answer. I have to think about it and kind of figure out what is the angle here. I can find the r pretty quick, and that's just the distance formula, I think, or the hypotenuse. Think 4 squared plus 3 squared and square root. So the square root of 9 plus 16, 3 squared and 4 squared, and that'd be 5. Now the angle in here, if I just do inverse tangent, and it's always going to be the y over the x, because the opposite side is going to be how far up or down you go. So it'd be 3 over -4. Again, the calculator doesn't know if you mean positive 3 over -4 or -3 over positive 4. It has no idea of what you mean, which that put it in this quadrant. If it was a positive, positive 4 and a -3. So if it's -3, positive 4 would be over here. So it's going to give me the right angle, but it might be on the wrong side. Okay, so when I do inverse tangent of 3/4 on that, I get -36.57. Now that means open down 36 degrees, but I'm obviously in the second quadrant, so that's not quite right. So this is 36.57, that means this is 36.57. So I could think 180 minus that. So 180 minus 36.57, and now it's 143.13. So it would be 5 comma, there's my polar coordinate. Okay, so again, if it's in the first or second quadrant, you're good. The first or the fourth quadrant, so on the right side, it'll figure it out for you. But if not, you're going to have to do a little bit of work. Let's think about it. So this guy here, again, right 3 up, or right 3 down 5, the calculator is going to give me the right answer on this one because I'm on the right side of the unit circle. But I've got 9 plus 25, and 3 squared plus 5 squared, take the square root, get radical 34. I'm just going to leave it as radical 34. I honestly don't know if MathXL wants a decimal or not. If it does, just take the decimal and round it. And now inverse tangent, and it's always going to be the y over the x. In this case, since it's on the right side, this is the answer. So you get -59.03, which is okay. It just means you're opening down 59 degrees, and that would be right 3 down 5. So this is right. It's just we got to write it the positive. So I'm going to do 360 minus that. So it'd be about 300.97. I'm just going to round that to 301. So it'd be radical 34 comma 301 degrees, or my coordinate, my polar coordinates. So when converting from coordinate form to polar form, the r is always going to be the square root of the x squared plus the y squared. Then to find the theta, we're going to do inverse tangent. I'll say theta equals inverse tangent of the y over the x, or it's going to be the inverse tangent of y over x, and then we have to add pi to that, because over here, I subtracted 36. I really took -36.57 plus 180, or pi. I'll put 180 here in parentheses. So this one, when it says or, you got to figure out which one it is. So it's not so clear. It's this one, if you're on the right side of if you're on the first and fourth quadrant, it's this. If you're in the second or third quadrant.